Thank you, Lenore, for introduction. I'm very excited and flattered to be invited here to speak about our company. The name of our company is BioHybrid Solutions. And I would like to start my talk with a question. What is common between detergent, jeans which have warning look, cheese, and antibiotics? And because I only have 8 minutes, I'm not going to wait for your answers. And I'm just going to tell you that all of these products, they either contain or they were made with enzymes. And Amber already talked about proteins, but I'm just going to go into that one more time. So enzymes are a type of proteins. They're nature catalysts. And proteins, they have very unique, complicated three-dimensional structures you can see here. This specific protein comes from egg white, specifically ostrich egg white, if you're interested. What happens, though, they have a lot of very interesting, very unique functions. That's why they've been used in many industries already. The issue, though, that they also can be denatured or ruin their properties quite easily. So for instance, if you heat them, they unfold and they'll lose their complex three-dimensional structure and they don't work anymore. So next time you cook egg for your breakfast, I want you to think about what you're doing. So it's no wonder then, because it is an issue that their stability is an issue. The industry of improving enzyme performance has seen exponential advances over the last decades. And how fast nowadays you can bring new enzyme products is really impressive. Even 20 years ago, it used to take, on average, 40 scientist years to bring a new product on. So nowadays, it takes on average about 2 scientist years. And coming to Silicon Valley, I couldn't help myself when I wanted to give an analogy of Moore's Law, that we hope that our company will help to fuel acceleration in this field synergistically with existing technologies. As you can see in Moore's Law, there shows overall acceleration and exponential advances in technologies, but there are also a set of subwaves of technologies. And I'm dreaming that our technology could be one of these subwaves for enzyme industry. So what we're actually selling is our nano-armoring process. So we can chemically engineer proteins to dramatically enhance their performance using polymer chemistry. So we take enzyme, which has this complicated 3D structure, and put less organized synthetic polymers around that. But because of the diversity of polymers you can put on their surface, you can change their behavior for different applications. If you need higher temperature stability, stability under acidic conditions, which can be useful for a number of applications. You can think about it as Captain America, where Captain America himself is an enzyme, and his shield would be our polymer coating. We have a number of benefits which we believe make our process commercially attractive. And we would like to fuel acceleration of product development with robust biocatalysis with enzymes. So we can improve stability and production rates of enzymes, orders of magnitude. We have quite simplified development cycle compared to other methods. We are less expensive than other traditional approach for polymer conjugation. And we also provide opportunity to use novel enzymes which are unstable. So that means you can have new products and new processes. So these are our current markets of our interest. We started a company in 2016 with work in industrial enzymes area, specifically in biofuels. And this year, we started working on more applications in green synthesis, which can be used for commodity and specialty chemicals, pharmaceutical compounds, agribusiness compounds. We're potentially also working with different type of partners and collaborators, and we see that there are a lot of interest for using our technology in therapeutic applications. And this is something we're also very interested in, but we realize it requires different type of investment and work, but we're hoping to have more interesting projects next year in this topic. And there's a lot of other areas which we could potentially go, and we keep that in mind, but we're also trying to stay focused. So as I mentioned, we started our company 2 years ago, and it was, back then it was 3 of us. I graduated from Carnegie Mellon Chemistry Department, and Chris Matuszewski here to the left of me, he was my PhD advisor, Department of Chemistry. Alan Russell is also professor at CMU in biomedical engineering. And I'm very excited that 2 years later, our family grew to 7 people, where 4 of us are full-time employees, which include both scientists who are working really hard to advance our technology, and also people some more on the business side to make sure our commercial development going well. And then I would like just to give you acknowledgements. It's been really exciting to work together with Chris and Alan to build this company. They've been working on this technology since early 90s. And I kind of joined in during my PhD, and it's really amazing opportunity to take your PhD research trying to build something commercial out of that. I'm one of those people who took probably like 99% of opportunities from Swartz Center, as Lenore mentioned. I'm Innovation Fellow. I participate in the SoftI Core program. It's been great working with Center for Technology Transfer with Reed. Meetings at Project Olympus were really helpful, and I also would like to mention Scott Institute, who were really helpful to showcasing our biofuel technology. To date, we were mostly funded through SBIR funding, which has been really amazing, and I would like to thank Department of Energy and National Science Foundation. And also, it's really, nowadays it's impossible to build something really viable in isolation, so having great partners and collaborators it's really been amazing for our technology. Thank you.